This is the ordinary reflux setup. During the lab, we had extra pieces. However, for the purposes of this video, this is the ordinary reflux system. As you can see, this is the Bunsen burner that heats up the round bottom flask. And this is the gas source that feeds the Bunsen burner. This is the loose clamp that holds the condenser. The condenser catches and condenses the evaporation from the round bottom flask. This is the tight clamp. The round bottom flask holds the solution, and this is the round bottom flask. This is the ring stand that holds the ceramic plate, shown here. And this is the water source. This is the clamp holding the condenser. The condenser needs to be loose so that gravity is allowed to make a proper seal. The seal is over here, between the round bottom flask and the condenser. There should be lubricant between the seal. If the clamp is too tight, it might lift the condenser. The water from the water source will flow in through the condenser through the bottom tube first. And here it is. This is the water flow. And it will flow out on top. And here is the water flowing out of the top tube. This is so the water flowing in is closer to the heat source. And when it's flowing out, it is further away from the heat source. The ceramic plate should not be too close or too far from the flame. The round bottom flask will be close to the ceramic plate and clamped at the neck with the tight clamp.
This setup is used for reflux. Reflux is a heating of a solution so that the lower boiling solvent evaporates and then condenses where the condenser and round bottom flask meet, and it goes back into the mixture. This keeps the reaction going without a loss of reagent or product. For the purposes of this lab, we did not use HBr directly. Rather, it used a beer salt and a strong acid, making HBr in the reaction. The reason for this is because HBr is not directly needed. Rather, it is the protons and the nucleophilic Br ions needed for this SN1 reaction. So, indirectly using a salt and an acid yields the same results. Then, HBr was produced in this lab, and its inhalation must be avoided. In order to prevent the release of HBr into the immediate environment, aqueous sodium hydroxide was placed in a beaker. HBr is a strong acid, while NaOH is a strong base, so the reaction will neutralize the HBr and NaOH. The funnel was submerged shallowly because incoming gas into the liquid may have caused NaOH to spill out. What are the benefits of reflux? It speeds the rate of reaction so that reactions that take a long period of time to occur can be done in short labs just like this one.